Hi, good day. Welcome in today's episode of Ep1 TV. I am your teacher Jay, and I will be here to help you in developing your logical reasoning and critical thinking skills. Is your learning activity sheet ready? What about your pen and paper? Great! Let's begin a fun and exciting lesson. For this lesson, you are going to learn how to generate patterns from a given succession of objects, numbers, letters, and symbols. When you were in grade 8, you learned about concepts related to generating patterns like inductive reasoning. The knowledge and skills you acquired are very important for you to understand how to generate patterns and sequences. Hence, let us review inductive reasoning and perform the activities that follow. But what does inductive reasoning means? Inductive reasoning is the process of observing data, recognizing patterns, and making generalizations or conjecture from observations. A conjecture is a conclusion made from observing data or an educated guess. At this point, you are about to learn the introduction to sequences and patterns. To understand better how to generate patterns, you will have to perform this simple activity. Please prepare the following: 5 strings and a pair of scissors. Let's do step 1. First, let us prepare 5 strings of equal length. Let's go to step 2. Cut the first string once. How many pieces are there? Cut the second string twice. How many pieces are there? Cut the third string thrice. How many pieces are there? Cut the fourth string 4 times. How many pieces are there? Cut the fifth string 5 times. How many pieces are there? Step 3. Based from your answers, complete the table. You have 15 seconds. Go! Great job! Now, let's proceed to step 4. If we have the 6th string, assuming we cut it 6 times, how many pieces would there be? Have you seen a pattern? If yes, describe the pattern and state your conjecture. Use a formula or equation in your conjecture, where y is the number of pieces and x is the number of cuts. Using your conjecture, how many pieces of strings can be made from A. 12 cuts, B. 24 cuts, C. 35 cuts, and D. 42 cuts. Show your solutions using the table. You have 10 seconds for each box. Go on and try. Time's up. Thanks for trying. Well, how did you find the second activity? Have you given idea on how to generate a pattern? Let us process your answers. Based from the task, the complete solution is shown in the table. From the table, notice that the number of pieces y of strings is 1 more than the number of cuts x. Thus, we can state our conjecture as the number of pieces y when a string is cut x times can be computed using the formula y is equal to x plus 1. Using the y is equal to x plus 1, we can now solve the number of pieces of the strings we have made from the cuts. For letter A, 12 cuts, x is equal to 12, y is equal to 12 plus 1 is equal to 13. For letter B, 24 cuts, x is equal to 24, y will be equal to 24 plus 1 is equal to 25. For letter C, 35 cuts, x is equal to 35, and y will be equal to 35 plus 1 is equal to 36. And for letter D, 42 cuts, x will be equal to 42, y will now be equal to 42 plus 1 is equal to 43. Those were the correct answers. Were you able to get the same answers too? If yes, very good. If no, I hope you were able to follow and understand our discussions about sequences and patterns. Based from the given activity, the number of pieces y is equal to x plus 1 when a string is cut x times represents a sequence. The word sequence means an order in which one thing follows another in succession. Again, sequence means an order in which one thing follows another in succession. A sequence is an ordered list. For another example, if we write x, 2x squared, 3x cubed, 4x raised to 4, 5x raised to 5, what would the next term in this sequence be? The one where the question mark now stands. The answer is 6x raised to 6. A sequence is a set of objects which is listed in a specific order, one after another. Each member or element in the sequence is called term. Again, each member or element in the sequence is called term. The term in a sequence can be written as a sub 1, a sub 2, a sub 3, a sub 4, so on, up to a sub n, which means a sub 1 is the first term, a sub 2 is the second term, a sub 3 is the third term, and a sub n is the nth term, and so on. Sequences are classified as finite and infinite. Again, sequences are classified as finite and infinite. Finite sequence contains a limited number of terms. This means it has an end or last term. Again, finite sequence contains a limited number of terms. This means it has an end or last term. Consider the examples. Days of the week: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. The first 10 positive perfect squares: 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. On the other hand, an infinite sequence contains a countless number of terms. The number of terms of the sequence continues without stopping, or it has no end term. Again, an infinite sequence contains a countless number of terms. The number of terms of the sequence continues without stopping, or it has no end term. The ellipses, represented by 3 consecutive dots at the end of the following examples, show that the sequences are infinite. Consider the examples. Counting numbers: 1, 2, 3, 4, 5, and so on. Multiples of 5: 5, 10, 15, 20, 25, and so on. Sometimes, a pattern in the sequence can be obtained and the sequence can be written using a general term. In the previous example, x, 2x raised to 2, 3x raised to 3, 4x raised to 4, 5x raised to 5, 6x raised to 6, and so on. Each term has the same exponent and coefficient. We can write this sequence as a sub n is equal to n x raised to n, where n is equal to 1, 2, 3, 4, 5, 6, and so on, where a sub n is called the general or nth term. Now, let's try finding several terms of a sequence given the general term. Are you ready? Let's start with the first example. Find the first 4 terms of the sequence a sub n is equal to 2n minus 1. To find the first term, we will let n be equal to 1. First step, we're going to use the given general term, which is a sub n is equal to 2n minus 1. Next, we will substitute n by 1. So that will be equal to a sub 1 is equal to 2 times 1 minus 1. Next, perform the operations. So you have a sub 1 is equal to 2 times 1, that's 2, minus 1. Simplify, you have a sub 1 is equal to 1. Find the second term. N will now be equal to 2. So you have a sub 2 is equal to 2 times 2 minus 1. Perform the operations. You have a sub 2 is equal to 2 times 2, that's 4, minus 1. Our a sub 2 is equal to 3. Find the third term. We will replace n by 3. So you have a sub 3 is equal to 2 times 3 minus 1. Perform the operations. You have a sub 3 is equal to 2 times 3, that's 6, minus 1. Our a sub 3 is equal to 5. Now, for the fourth term, we will replace n by 4. So you have a sub 4 is equal to 2 times 4 minus 1. perform the operations. You have a sub 4 is equal to 2 times 4, that's 8, minus 1. Our a sub 4 is equal to 7. Therefore, the first 4 terms of the sequence are 1, 3, 5, and 7. How was the first example? I know you want more. Let's move on. Finding the general term given several terms of the sequence. Write the general term of the sequence 5, 12, 19, 26, 33, and so on. What can you notice about this sequence? That is right. Each term is 7 more than the previous term. We can search the pattern using the tabular form like this one. In the pattern, the number of times that 7 is added to 5 is 1 less than the nth term, or quantity n minus 1. Thus, a sub n is equal to 5 plus 7 times the quantity n minus 1, where you have to equate a sub n and 5 plus 7 times quantity n minus 1. Then, apply distributive property of multiplication, so that's a sub n is equal to 5 plus 7n minus 7. Finally, combine similar terms. That's a sub n is equal to 7n minus 2. Therefore, the nth term of the sequence is a sub n is equal to 7n minus 2, where n is equal to 1, 2, 3, 4, 5, and so on. Very good! Fasten your seatbelts because we are going to move to the next example. Find the general term of the sequence 1, 1/4, 1/9, 1/16, 1/25. What happened to 1? Right. We changed it into fraction form so we can generate a pattern. Can you see any patterns from the denominators? Yes, that's correct. The denominators are integers squared. Therefore, the nth term of the sequence is a sub n is equal to 1 over n squared, where n is equal to 1, 2, 3, 4, 5, and so on. I hope everything's clear. I know that you are really excited for the next part of this lesson. Now, it's your turn to apply the concepts on sequences and patterns to find the specified terms of a sequence when given its general term and vice versa. Item number 1. A sequence is Item number 2. A term is Item number 3. A finite sequence is, while infinite sequence is. Item number 4. The key steps to find the specified term or terms of a sequence when given the general term are. And item number 5. The key steps to write the general term of a sequence when given some terms are. Great job! Now, let's see. What's your score? Congratulations for doing your best. That concludes our lesson for today. See you again in the next episode. I am Teacher Jay also. Please bear in mind that learning math is fun and easy. Be also, be awesome. Only here on Ep1 TV.